Hello, my name is Steven, and this is Simple Traffic System. It's a traffic system that I've created with the bare minimum features required for background traffic simulation, and it also uses the C# job system and burst compiler, which are new to Unity. And by using this, I'm able to create a high performance traffic system that does just that. It acts as background traffic. So I'll go ahead and demo what's in the scene really quick. And what we have is, let me go ahead and actually make this a little bit bigger. So this will be the scene view. And here we can see we have some gizmos being drawn that help you visualize what the waypoint route looks like. There's about 100 waypoint routes that are interconnected. So that means that the final waypoint of any particular route will be connected to the first waypoint of any other particular route. And that's what allows me to create some traffic intersections, for example. So here we can see I have the traffic intersection selected. And these are primarily made up of 4 waypoints that will just help guide the car as it travels through the intersection and allows it to turn in a more realistic manner. The straight routes that may not require an additional intersection route, those can just be connected directly. Again, the intersection routes are just for helping make the car turn and travel the path that I'd like it to travel. And here I have all of the other routes selected. So by selecting a lot of these at the same time, it's obviously performance intensive to draw that many gizmos. There's a scriptable object where we can turn off the gizmos. So they're really just for visualization when you need to debug something. At this point, we don't really need to debug anything else, but I'll leave them on because I'm going to go into a demo scene and show you how to configure this in just a moment. So I'll go ahead and press play, and I will maximize this so we can see everything. So in the scene, there's about 350 cars, and we're running close to 200 frames per second. I have my screencasting software running, which slows it down a little bit. In the build, this scene, for a PC build, I have a 1080 GTX, and I have an i7 6800K. It's not overclocked, but the scene will run around 500 frames per second in the PC build, and you could go ahead and check that out if you're interested. There's also a WebGL build where this runs at 60 frames per second in Chrome on this machine. And the current CPU calculation is about 7 or 8 milliseconds, which is pretty good considering how many different vehicles there are. Now we could click the different cameras to basically get more of a street view to see what the cars are doing. All of these cars have a rigid body attached to them, and they have 4 wheel colliders, so the wheels rotate on the cars. There's also some LODs attached. LODs are also attached to the street lights, and that makes it so that basically when the camera's not close to it, those objects won't be rendering. But the point of this is not to jam as many cars as you can into a scene. It's to make it so that the traffic system is not an expensive process. Background cars are just that. They're background cars. They're meant to make the scene look better, but at the same time, you don't want to spend most of your game or your scene's performance on them. And that's why I'm using the C# job system and burst compiler. So with this setup, I can have as many or as few cars as I want, and I know that they're not going to contribute on a high level to the processing power. And whatever they they do contribute, it's being spread across all of the available cores because of the job system. So that's a rundown of what the system is and how it works. And now we can go ahead and just create a new scene. So in this new scene, let's go ahead and create a plane. And we can also, on this plane, let's set a different material so we can see a little bit clearly. I'll also reset the position of this plane, and I'm basically just going to be working in the scene view for right now. I'll increase the size of this plane. Actually, let's make it pretty big. And now we can set up some traffic routes. So the first thing I'll do is select Tools, Simple Traffic System, AI Traffic Controller. We need one of these in the scene, and only one. It's a singleton. This is what all of the AI traffic will register to. And it has the job system in it, so all of the AI traffic jobs basically run in parallel, and that's where the power of it is. So next we'll select AI traffic waypoint route. We could also press Ctrl-Alt-R to spawn this in case you want to more easily set up traffic routes without having to actually go in, and it just saves you a few actions. So anyway, we have our first waypoint route. Let's go ahead and actually give that a number. So this will be AI traffic waypoint route 1. And when we have a route selected, we can hold down Alt and left click in the scene view. And wherever we click, we'll spawn a waypoint. And if we want to move these waypoints, they're just objects. We can go ahead and move them. They currently have a mesh render on them. You can disable that, and you should. But for visualization, it's sometimes easy to have a mesh render on these. Now, every waypoint that you place on the route, you want to make sure that the cars are actually going to hit those waypoints. If the car misses a waypoint, it's going to try to reach for the waypoint that it's aiming for. So always make sure that they're laid out in a way where the cars will always hit them. So now that that's said, we'll go ahead and add our first AI traffic car to it, and we can press play. At this point, the vehicle can drive along the route, and once it reaches the last waypoint, waypoint 11, it doesn't have anywhere else to go, so it'll stop. Okay. So now with the waypoints, what we can do is we can see that they have some options. Let's go ahead and enable stop driving, and we'll also use the onReach waypoint event. And what we'll do with that is we'll actually assign the directional light, and we'll just turn it off. So you can hook up your own scripting functions with this to trigger different events. But at this point, the AI vehicle did stop driving, and it also turned off the directional light because that's what we assigned in the onReach waypoint event. So let's go ahead and remove those two, and we'll set up another route for this waypoint to connect to. So Ctrl-Alt-R, and we'll name that route 2. And here I'll just, I'll select it, Alt and left click, add some more waypoints. And now we want to select the final waypoint of route 1. And in this new new route points array, we'll drop in the first waypoint of route 2. we could faintly see a gizmo line being drawn between those two routes. I'll also go ahead and increase the amount of cars spawned on this first waypoint route. And then press play. Here we go. We can see we have 5 cars spawned now. And when the vehicle reaches the intersection, it has a connected route. So it will continue to drive through until the end of that route. And that's basically the building blocks and the basic rules that these waypoint routes and these vehicles use. As long as there's a path for it to travel to, it will continue driving. Once there's no path, it'll stop. And at this point, the vehicles are using their sensors. The back vehicles are using their sensors to stop because the front vehicle stopped. So if I were to take this vehicle, for example, and move it, the other vehicles would try to go to that position. And that's basically how that works. So now let's go ahead and create 2 more routes and create an intersection and hook up a traffic light to it. So we'll go ahead and collapse those. Control-Alt-R. Create a route here. Set up the points. We'll name this route 3. Control-Alt-R. Set up some more points. This one will be route 4. Then we'll take the final point in route 3 and connect that to the first point in route 4. And in route 3, we'll assign some traffic cars. And now we can play and see what it looks like. So we will need to set up some traffic lights because the vehicles the sensors are not going to be enough for them in this scenario. So we can see that because the cross traffic and the timing, sometimes they're just not going to work right. So to solve that, what we'll do next is add a traffic light manager. So AI traffic light manager, you can also press Control-Alt-L to spawn this into the scene. When this is spawned, it'll have a single AI traffic light. So let's just go ahead and lift this up and put it above this route right here. Doesn't matter where you put it. So what we want to do is we want this traffic light to control this route. So if this traffic light is green, cars are allowed to exit this route. So we'll select our AI traffic light and we'll assign waypoint route 1 to that. And we want to set up a traffic light for route 3 as well. So what I'll do for this traffic intersection, I'll duplicate the AI traffic light, bring it over here, and I will assign route 3. So AI traffic light 1 and AI traffic light 2. So AI traffic route 1 is assigned to route 1. AI traffic light 2 is assigned to route 3. And both of these lights will be controlled by this manager. I'll create another cycle. So the first cycle in the sequence will control AI traffic light 1, And the second traffic light in the sequence will control AI traffic light 2. And we'll set their on duration. Let's set that to about 8 seconds each. And now when we press play, we can see that the first traffic light that's on in the sequence was AI traffic light 1. Once that one turns red, there's a timer in the background, and I'll probably expose some of those variables. Then the next light will turn green, allowing traffic to pass through. So the traffic will actually stop when it's yellow. Now this one's green, so these cars can go. And at this point, we have a traffic management system set up for our intersections. And the way that these work is that if the vehicle is between the last two waypoints, it will respect that traffic light. So if we find that the vehicles are stopping a little too early, we could push these up a little bit more. And now the vehicles will actually stop closer to where we want them to stop. And at this point, you would just scale up, interconnecting more routes, creating more lanes, and assigning the routes to traffic lights to control those lanes. And that's about it. This is simple traffic system. It's a high-performance system that provides a lot of modularity for you to be able to create different types of traffic simulations. The last thing that we'll cover is how to create a custom vehicle prefab. So what I'll do is I'll duplicate the AI traffic car, and I'll open that up. And then I brought in Complete Vehicle Pack V2 from the asset store. This is a mobile optimized vehicle package. I'll bring in Hybrid A, and I'll just disable it for now. One of the things that we want to do is make sure that we have as few transforms as childs of the root as possible. This will make the car more performant. So because of that, the actual body is on the top level of the prefab, and what I'll do is I'll replace that. So I'll go ahead and I'll ping the hybrid, and I'll replace that mesh in the mesh filter, and then I'll grab that material and I'll replace that as well. Now, because this vehicle model is not using the standard shader, actually it is using the standard shader, I swapped it, but by default it's not. It requires an emission mask. So that's the way the brake lights work. You need to have vehicles that have emission masks and make sure that it's just the brake lights that are visible. And then when the emission is turned on, those brake lights will illuminate by enabling that emission color, and you would just set your intensity high. But since there's no mask for this, it's not going to work. So for that reason, I'll just set the intensity really low, basically disabling the brake light feature. And this is done because if we use actual lights for the brake light, that's going to impact performance pretty heavily. So we don't want to have lights unnecessarily. So now that we have the new body mesh set up, we can actually disable the use material manager option, because we don't want the material manager in the scene to assign a new material, because we created a custom prefab. And we don't want that material manager to assign a brake light either. What we'll do is we'll assign the car to material. which is this car's material, to the brake light, but the emission is not going to actually do anything. So the next step would be to actually unpack this prefab completely. And we could take these wheels and we could just pull them up. So our old wheels, we're just going to turn off for a moment. And in this wheels drop down, we just want to replace them. So the front right wheel, we'll assign that first. And we'll assign the transform. Front left wheel, we'll replace that next. And then the back right wheel. And then the back left wheel we'll replace. So now that those are all gone, we can delete the old wheels. We can delete the body because that's at the root. Now inside of this AI traffic script, we have an align wheel colliders button, and what that will do is, for the most part, it'll move the wheel colliders to the right position. What I notice is I'm seeing additional wheel colliders here, and that's because that vehicle model actually had wheel colliders on it. So that's something you want to pay attention to. You don't need a rigid body on this either. So I'm going to remove the rigid body and the wheel colliders because they're just going to basically mess up the vehicle. So now we can see we have the appropriate amount of wheel colliders, and I'll go ahead and click align. And that'll, for the most part, move it to the right position. But what we'll want to do is go into orthographic mode. And we want to actually just bring these up a little bit and increase their radius. Let's see. Yeah, that looks good. Actually, I could probably make it a little bit smaller if I wanted to, and that would be okay too. All right, so now this traffic vehicle is set up. We've disabled the material manager. We assigned the new meshes. Let's go ahead and bring it into the scene and make sure it works. So go ahead and replace some of the old references. So now we have a mixture of the default car and the new car prefab that we've just made. And if we zoom in, we could see that, let's actually get this light a little different. So we can see the cars here. His wheels, for the most part, look proper. They're spinning, and he's driving. That's about it. So at this point, we've gone through the traffic system, we've gone through the traffic light system, and we've gone through the traffic cars, and we've basically created our own custom car model. At this point, there's not really much to cover. Thanks for checking it out. Bye.